Welcome to Dr. Tarazi's Math Site. This video is one of a series covering the released Ohio State math questions between 2017 and 2023. Geometry makes up almost 1/3 of the test questions. Standards 8.G.6-8. Understand and apply the Pythagorean Theorem. Analyze and justify an informal proof of the Pythagorean Theorem and its converse. Apply the Pythagorean Theorem to determine unknown side lengths in right triangles in real-world and mathematical problems in 2 and 3 dimensions. Apply the Pythagorean Theorem to find the distance between 2 points in a coordinate system. This is a very important standard, 3 to 4 questions on the test every year.
Hello and welcome. Here is what you need to know before we get to the examples.
First, you need to watch this video. Distance between 2 points in a coordinate system.
Yes, if we have 2 points, A and B, and we want to find the distance between these 2 points, A is x1, y1, B is x2, y2. You notice from here to here is x2 minus x1. From here to here is y2 minus y1. And then you apply Pythagorean Theorem to find the distance is square root of x2 minus x1 squared plus y2 minus y1 squared.
Recommendation.
To make the most of these videos, I suggest pausing the video when you see this button, solving the problem, and then resuming the video to check your answer.
Example 1.
In this example, Beth draws triangle PQR. She also draws a square with side lengths PQ, a square with side lengths QR, and a square with side lengths RP. Beth states that the sum of the areas of 2 of the squares is equal to the area of the third square. For which type of triangle is Beth's statement always true? And here, giving us options, right triangles, acute triangles, scalene triangles, isosceles triangles. So if you watch the video about Pythagorean Theorem, you will find out that I started it with something like this. So this is your right angle triangle. This is PQR. This PR, that's the square she drew, and that QR, that's another square, and then she drew this square. And she found out that the area C is equal A plus B. And this is only true for right angle triangle. Only true for right angle triangle. That's Pythagorean Theorem. So area A plus area B is equal to area C. That's where we got the A squared plus B squared is equal to C squared. So the right, only true for right triangles. Only true for right triangles.
Example 2.
Again, you can pause and solve it and come back and check your answer. So here we have a right rectangular prism is shown. What is the length AB to the nearest tenth of a centimeter? Now, you need to remember that when you have a right triangular prism, all these angles are 90 degrees. All this is 90 degrees right here. This is 90 degrees here. This is 90 degrees here. This is 90 degrees down here, see? All these angles are 90 degrees. So now to find AB, you need to find a triangle where AB is one of the sides. So I call this is C, this is D. I draw a line here. Now I have now a right angle triangle like there, okay? So that's one of them. I put it here. I don't know AD, I didn't know AB. I only know BD, which is 12, given. Now here's another triangle, also right angle triangle. I'm putting it right here. So now if I can calculate AD from this triangle, I can use it here to find AB. So use the theorem now, call this x, that would be x, which is x here, right here too. So apply the Pythagorean theorem. 4 squared plus 3 squared is equal to 25, so x is equal to 5. And remember, the 3, 4, 5 is very classical example of sides of a right angle triangle, okay? Okay, so now I got this 5. Now I can use again the same theorem to find z. So 5 squared plus 12 squared, 25, 144, 169. Square root of 169 is 13, and this is one of the options given to you.
Example 3.
Right triangle MNP is shown. What is the length of MN? So this is very straightforward applications of the theorem, okay? So we want to find this here, okay? So let's apply the theorem, Pythagorean theorem. Mn is square root of 4 squared plus 6 squared. If you want to start like this, putting Mn squared is equal to 4 squared plus 6 squared, that's fine. And then you square root both sides, okay? You get square root of 16 plus 36, square root of 52. It happens to be C in this example. So I hope you got it right.
Example 4.
A cone has a slant height of 25 inches and a radius of 7 inches as shown. This is the radius. This is the radius. This is the slant height, okay? This is the height. So we want to find h. In this example, I have the hypotenuse, but I don't have one of the legs is missing. This one here, I need to find h. So I apply the theorem, h squared plus 7 squared is equal to 25 squared. Subtract 49 from 625. H squared is 576. Now you have to get the square root of this number, which happens to be 24.
Example 5.
A right triangle has a hypotenuse of square root of 50. What are possible lengths of the two legs of the triangle? Remember now, when you see this are possible lengths, expect to have more than one good answer, okay? So anytime you see a triangle like this with right angle here, think of Pythagorean theorem, okay? Let's apply it. A squared plus b squared equals square root of 50. That's this one here, given, squared. So that gives you 50 here. So now a squared plus b squared is equal to 50. It's like now I'm asking you to find a and b to satisfy this equation. And obviously you will have an infinite number of possibility here, okay? So pick up the easiest possible answer is 5 and 5. Because 5 squared is 25 and 5 squared is 25. 25 plus 25 is 50. Or you can have 1 and 7. That works. You can have 3 and square root of 41. So in fact, there's an infinite number of solutions. In the test, it's enough to give one if they don't ask you. If they only ask you for one, you just give them this one here. If they ask you to have 2 possible answers, then you can maybe give them these 2 here. Okay?
Example 6.
Isosceles right triangle ABC is shown in a right triangle DEF. Angle D is the right angle. The length of DE is 2 times the length of AB, and the length of DF is 4 times the length of AC. How many times greater EF than BC? Of course, we need to do some drawing here to try to see what's going on. Before that, let's see what happens in this triangle. I'm going to apply the theorem, Pythagorean theorem. 3 squared plus 3 squared is equal to BC squared. 18, that's 9 and 9. So that's square root of 18. So this is now I know how much is BC. Now I need to draw a triangle DEF. Just draw any one a little bit larger. And then what he's saying here, the length of DE is 2 times the length of AB. AB is 3, so this one will be 6. And the length of DF is 4 times the length of AC. 4 times 3 is 12. Now you apply Pythagorean theorem here to find EF. Okay, 6 squared plus 12 squared equal to EF squared. 36 plus 144, 180. So EF is square root of 180. I'm going to put it here. Now, what is the question here? How many times greater is EF than BC? How many times this is greater than this? So you divide this is divided by this. You put them under one square root. 180 divided by 18 is 10. Square root of 10 is about 3.2 times. This is about 3 times more than this. Okay? I hope you got it right.
Example 7.
Point M, P, and S are shown on the coordinate grid. Which calculation can be used to find the distance between point M and P? Distance between 2 points, as I did it in the introduction here. So let's look at the, you can create a triangle here, right angle triangle. So you need to find the distance between P and M. Look at the options given. Count the number of boxes between M and P. There's no boxes between M and P, so that's not going to work. Add the lengths of MS and the lengths of PS, then divide by 2, which means you add this plus this, divide by 2. No, has nothing to do with that. Find the difference between the lengths of MS squared and PS squared. No. Now look at this here. Square the lengths of MS and PS, then square root of the sum, then add them and get the square root of the sum. That's exactly the application of Pythagorean theorem. So that would be your correct answer.
Example 8.
This is a very interesting example. Henry is going to ride his bike to and from school each day. He wants to ride the least possible distance. The map shows the possible routes that Henry could ride each day. Now, there's a problem here. It says there's a condition here. The park near Henry's house is closed before school, so he cannot take it in the morning on his way to school. So he cannot ride through the park on his way to school. Okay, so again, here he can go this way in the morning or this way in the morning. In the afternoon, he can come back this way or this way or this way. So basically, I need to know the lengths from here to here. I need to know the lengths from here to here, from here to here, from here to here. This is easy. I know. I can count them. 1, 2, 3, 4. I can count them. Those I can count them. Those I can count them. So I need those. So I'm going to create right angle triangles. Okay? So I'm going to find, this is called W, X, Y, and Z. So W is, this is 1, and this, you count those, you get 13. So 1 squared plus 13 squared equal 170. Then W will be 13.04, the square root, okay, of 170. Now we are going to find X. X squared is this distance here. This is 5. 1, 2, 3, 4, 5. And this one here is 12. You can count them, 12. So you get 169. You square root it, you get 13. Now Y, look, 1, 2, 3, 4, 5. 1, 2, 3. 5 squared plus 3 squared is 34. The Y is 5.83. Z is 4 squared plus 4 squared is 32. That Z is equal to 5.67. Now let's see the length of each of these routes. Route A, now I multiply all of this by 100 because every box here, every one of these here units is 100 yards, okay? So 100, look at A. Is this distance from here to here, which is 13, A. From here to here is W, which is 13.04, plus you count those 16. You multiply them, you get this is yards. Okay, now let's look at route B now. Route B, which is X. X is 13 plus 5 here, 5, plus Y, 5.83, you get 2383. That's yard. All of these are yards. And you find route C to be 2,767. So now let's put those back here. Okay, here's route A, route B, route C. In the morning, I can't take route B. I can't take it. So I have to take A or C. Which one is shorter? C. That's why you pick up C from this drop down choices. And then on the way back now I can use this. This happens to be the shortest of all the three of them. Then I can take route B. So if you add the two distances here, the two amounts, you find it to be equal to 5,150 yards. Your answer might be a little bit different depending upon the routing that you did to your number, okay? And the rounding that you did to your number.
Example 9.
This is an interesting example. Port A is shown on the coordinate grid. That's A. The distance between point A and point B is 5. Now, what do I know about point B? The x-coordinate of point B is -2. So B should be on this line somewhere. Okay, you can choose put any point anywhere here you want. So if I put B here, so now what do I have? I know from A to B is 5. That's given. Now from this here to this here is 3. Calculated 1, 2, 3. Now remember the rules 3, 4, 5. 3, 4, 5. This will be 4 for sure. But if you apply Pythagorean Theorem, get 3 squared plus y squared equals 5 squared. 9, subtract 9, 16. So y is equal to 4. Y is equal to 4. Also, -4 would give also another option. And so 4 or -4.
Example 10.
A right square pyramid is shown. What is the length of the height h to the nearest tenth of centimeters? So I need the height h here. Again, I look for a right angle triangle. This will be one of the legs of the triangle. So I can do like this. I know this is 8 because that's half of 16. Now I apply Pythagorean theorem on this triangle right here. 8 squared plus h squared equals 13 squared. H squared is equal to 105. Now you square rooted, you get 10.2, and that makes sense. 10.2, it's more than 8 and less than 13.
Thank you for watching. If you would like to have a copy of the PowerPoint presentation, please leave your email address in the comments section, and we will be happy to email you a copy.
Thank you, and see you soon.
Thank you for watching. More videos to come. Please subscribe.